So, hello everyone, my name is Austin Jamais, and over the past year, I've been working on a project where I utilize D4N rack locality with Kubernetes. So the things I'll talk about in this presentation are the motivation of past efforts. So I'll go over kind of the history of why we need all these different technologies like D4N and what problems they solve. I'll give a summary of what D4N is. I'll give a physical architecture overview of what the physical system looks like in a cloud environment. I'll go over the software system of my implementation with Kubernetes and D4N. I'll go over the feature work that I can see a potential path after this project is completed, and I'll go over the things that I've learned from this project. So, motivation for previous efforts. So in a cloud environment, there is a bisectional bandwidth with higher oversubscription at higher network layers, meaning that if a machine in one rack wants to query data or send requests to another machine across the data center, it would have to go through a bunch of different network switches, and as there are more network switches, then that bandwidth could be oversubscribed or overused, and which leads to slower data fetches and sends. So to attempt to fix this, we would want to try to achieve data locality by caching frequently accessed objects within the same rack to avoid traversing up the network layers. And basically, we would want to have a cache, which is what D4N is. And this is going to be, in comparison to per cluster caches, D4N would be better because a per cluster cache would have a lot of redundant a lot of the same data per cluster rather than a shared cache that's shared between all the clusters. So a brief summary of D4N. So in my project, I assume that D4N will be deployed by the data center itself. There will be one D4N node on each rack. D4N is a cache that has read and write capabilities. It has a global object directory, meaning that if there's a cache miss to the L1 cache, then it'll search through a highly available key value store to see if any of the other D4N nodes has that object. And if it doesn't, then it'll forward that request to the Ceph Rados Gateway, RGW, to the data lake. So this is what the physical architecture looks like without Kubernetes. We have a bunch of racks with D4N, one D4N node on each rack and a top of rack switch. And each worker machine below the D4N nodes would basically send requests to that D4N node via DNS or IPs. So in a Kubernetes, so this is the physical architecture with Kubernetes clusters. So what makes working with Kubernetes clusters harder than a normal machine is that we would need to have some sort of DNS service for the pods itself. So, and what makes this hard is that pods are ephemeral. So a pod could exist in one node and it could exist in another node. So we would want to have a Kubernetes service that basically says, okay, this pod is coming from this node, and this node is in, let's say, we're going to call it a zone. This node is in this zone, which is basically, let's say, the rack. And since this node is in this rack, then we know that since there is one D4N node, we know that this node can forward the requests to this D4N IP address on this rack. So the overall goal is to have requests from Kubernetes to automatically be redirected to its rack local D4N cache. And this is the software architecture of basically how it's all connected. So we'll have a pod in a node, let's say that it's in zone 2. We will have the pod send its request to the kube proxy, which is basically it's the thing that manages the network forwarding, and it'll send it to the service. And now that service sees that, oh, I'm in zone 2 because the node has a label of zone 2. So I'm going to send this request to the endpoint slice associated with zone 2. And that endpoint slice has a list of IP addresses. And in our case, that IP address will be 1, and that IP address is the IP address of the D4N node, which is in zone 2. Now, at the bottom, we have a Ceph manager module and a Kubernetes operator. Now, what the Ceph manager module will do is whenever the Kubernetes operator asks for the IP addresses of the D4N nodes, the Ceph manager module will take a look at its configuration of the Ceph cluster, and it will forward all the mappings from the worker nodes to, it will forward the one-to-one corresponding mappings of the worker node to the D4N rack local node. So once it sends that to the Kubernetes operator, it will determine, okay, I noticed that this endpoint slice is no longer used, or we no longer need to have an endpoint slice for this D4N node because maybe the data center took it down, or maybe the data center added another one. So it'll basically say, okay, I found a new one, or I noticed that it got deleted. So it will create or delete an endpoint slice associated for that D4N node within the service. So some of the future work after that this project has completed could be related to cache-informed scheduling. So in a previous paper, there was a paper that proved that you could have cache-informed or data dependency caching, which means that if you know which data depends on which data, there's an algorithm that you can effectively put data into each cache. And with this Kubernetes, we could provide hints on which pod to run workloads so that given that the data is in a certain cache, we can schedule those workloads on a certain rack with that associated data. And since D4N has a write tier compared to the D3N projects, we can also associate those sets of pods to those same write tier topologies. And after this, I would like to perform experiments comparing the workloads with using Kubernetes and without using Kubernetes to see if there is actually a performance increase or decrease. So the things I learned over the process of this project is that the Dunning-Kruger effect is real. When I started out the project last year, I was taking a cloud computing course, and I was thinking, okay, I'm learning a lot of these new different technologies, methodologies, how these design patterns work in the cloud environment or cloud native applications. I actually was just repeating what people were being told me. And when I went back to this project, and after having experienced a lot more work in the cloud space, I realized that past me did not know what he was talking about, especially after re-looking at the previous files I wrote. And I learned how to work with physical or real objects with virtual objects. So that could be a virtual node or a physical machine. That can be a IP address or a virtual IP address, which is like for example, the cluster IP for a service, and ports and etc. And I think that this project allowed me to think about the cloud architecture and how data moves around in a cloud architecture, and being able to communicate my thoughts and write it down on the board and try to reason like why a certain thing would make things faster, or why a certain thing would work, or how to get information from one place to another, and so on. And last thing I learned was that communication is key. I think I'm a strong believer in the Feynman method, where if you try to teach other people, then sometimes you might catch yourself in saying something wrong. So I think that communicating my thoughts is something I should have done a lot more back then, to catch my Dunning-Kruger effect faster rather than later. And yeah, thank you. And special thanks for Oran for being the PI for this project, Heidi for being my manager, and Amin and Sumatra for being the PhD students that I could bounce my thoughts off of. Yeah, that's my presentation.
You're the first intern to ever mention the Dunning-Kruger. Awesome. I love it.
Thank you, Austin.
Thank you.
Sorry I'm not there in person. I misunderstood where it was happening.
So you said you'd want to follow up by measuring the differences in performance with and without Kubernetes. So did you mean using D4N in some kind of a virtual machine setup instead of a containerized setup, or did you mean bare metal versus Kubernetes, or what? I wasn't quite clear on that.
So I think the people working on D4N itself, they're going to run it, or they're running experiments to determine whether or not D4N is actually going to be faster than previous methods. I think with my project, it's going to be more on, I think that Kubernetes is going to be the variable to test for. And I think that would be on bare metal machines.
Okay, so given that you have a certain application you want to run that's big enough that it needs more than one machine, would it be more efficient to like dedicate machines or to use Kubernetes with D4N?
Right.
Got it. Okay, cool. That's actually a really interesting question in the AI space, because people are looking at having to bring in all the data to run the AI models, and what's the fastest, most efficient way to do that. And they're going back to that same question.
Bare metal versus
any other thing. Shouldn't I just have a machine under my desk instead of paying all this overhead to run in a containerized environment?